one more formula of that type so that in MCQs you can use directly. 12th level MCQ. Second note, when one drop splits into n droplets, again same concept, area of first drop, area of n droplet, difference into T will give energy. Let capital R, comma, small r be the radius of big drop and smaller droplet respectively. Big drop and smaller droplet respectively. Therefore, volume of one big drop equals to volume of n smaller droplets. Therefore, 4 by 3 pi r cube equals to n times 4 by 3 pi small r cube. So capital R is n raised to 1 by 3 into small r. Area of one big drop A1 equals to 4 pi capital R square. Area of n smaller droplets in bracket A2 equals to n times 4 pi small r square. Just copy till this.
Yes, sir.
Is completed full till this?
Done, sir.
Therefore, change in energy, comma, du equals to T into dA. So T into 4 pi capital R square n raised to minus 1 by raised to 1 by 3 minus 1. Completed now? Full till last line?
Yes, sir.
Everybody is done?
Yes, sir.
Explain why surfaces of liquid are either plane, that is horizontal, or concave or convex. Explain why surfaces of liquid are either horizontal or concave or convex. See, there are actually three types of liquid. One which is completely wetting the wall of container, other which partially wets the wall of container. Completely wetting is pure water, partially is like kerosene, and not wetting is like mercury. When you pass mercury through glass, it will just pass without touching the wall of container. Kerosene, partially it will be wet and partially dried. Pure water, completely wet. So these are three types of liquid. Force of attraction between similar molecule is called as cohesive force. And force of attraction between dissimilar molecule is called adhesive force. Distance up to which molecular influence exists is called as molecular range. That means from one molecule up to certain distance, other molecule is attracted. That is called molecular range. If I take molecule as center and draw sphere with radius molecular range, this sphere is called as sphere of influence. So four things you have to remember. First, cohesive force means force of attraction between similar molecules. Adhesive, force of attraction between dissimilar molecules. Molecular range, distance up to which molecular influence exists. And sphere of influence, imaginary sphere drawn with molecular center and molecular range as radius. So I have to explain why there are three different types of surfaces for three different liquid. One is plane, other is concave, other is convex. Three liquids are completely wetting, partially wetting, not wetting. See one by one. Consider liquid such as water which completely wets the wall of container. Completely wets the wall of container. If I consider liquids such as water, which is completely wetting the wall of container taken in a glass container. This is liquid such as water taken in a glass container. See, always just remember, if this is one vector, this is longer vector, then if you draw resultant, resultant will always make small angle with large vector. So resultant makes small angle with larger vector. Like if this is, let us take 20, this may be greater than 20. So small angle with larger vector. If both vectors are same, then diagonal will make same angle. That means it will behave like bisector. So these 2 points just remember, which is actually from vector chapter. Resultant makes small angle with large vector and same angle if the vectors are same. So we are talking about liquids such as water, which completely wets the wall of container. In such type of liquid, it is found that adhesive force means liquid and glass container molecule, and cohesive force. See, this is, if I draw sphere of influence, air वाला no force of attraction, तो ये vanish कर दो. इसका exactly resultant half पे आएगा, इसका resultant इधर आएगा. ये container के साथ है, and this is liquid के साथ. So here I am drawing exactly at the center FC. F means force, C is cohesive force. Now both FA and FC are equal. So where will be resultant? Exactly at the bisector. Just now I explained. Hello?
Yes, sir.
So resultant will be where? It will be at the bisector. So this will be our resultant. Okay.
Yeah.
So now if you complete this parallelogram, resultant falls on the wall of container. So by property of equilibrium in case of liquid, always the liquid surface tries to adjust itself in such a way that it is perpendicular to the surface. So for equilibrium, this is resultant. Surface will try to become horizontal, so that resultant is making 90-degree with the surface. Hence we get surface as horizontal in case of liquid which wets the wall of container. Case 1 followed first one.
Yes, sir.
Just write this 2 line and draw the diagram, then I am explaining. Value of Fa and Fc are same in case of liquid which is completely wetting the wall of container. Because they are equal, their result is exactly at the half, that means on the wall of container.
can you please repeat the meaning of cohesive and adhesive force?
No, I can't repeat. I am recording. I will send. If this happens continuously, I am mad or what? Every time I will repeat 10 times. So I am explaining while explaining. I am repeating 10 times. You get disconnected. All of a sudden, you come. You say again, repeat. Notes are self-explanatory. If somebody can read English, they can understand what I told. एक्चुअली सर लेक्चर था 10 बजे करूं, लेट हो जाएगा। नहीं चलो कर लेता हूँ बात। 2 स्टूडेंट का फोन आया था सर यहाँ से, अपने घाटकोपर से। तो नहीं, ध्वनिशा ध्वनिशा का, हाँ ध्वनिशा का भाई अपने पास है ना, मोहित शाह। हाँ, तो एक तो वो टाइम टेबल का सर कैसे करना है, मैंने उसको कल रैंडम रखा है लेक्चर। हाँ 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 हाँ, नहीं वो तो हाँ 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 हाँ, क्योंकि क्या एक बार अगर टाइम टेबल सेट हो गया तो फिर गड़बड़ नहीं होना चाहिए। तो उनको सर हमको फीस कितना बोलना है, वही 30 ना? हाँ हाँ समझ, वो तो पता है मुझे 25। हाँ ठीक है क्योंकि मैंने उनको ठीक है वही बोला उनको, लेकिन हाँ हाँ नहीं मैंने क्या बोला था कि आई हैड प्लान 35 बट आई डिस्कस विद द सर, मैंने ऐसा बोला उनको। सो वी हैड प्लान 30, तो वो ऐसा बोल दिया उनको, चलेगा ना? ठीक है ठीक, यस ठीक है। हाँ सर ओके सर, वो ठीक है। हाँ डाल दिया वो, हाँ डाल दिया। हाँ हाँ ठीक है। हाँ 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 हाँ, ठीक ठीक ठीक। हाँ ठीक हाँ ठीक मैं हाँ 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 वो है। नहीं मैंने क्या बोला है, ऑफिस ना 11 to 4 खुला रखने के लिए बोला है, और वो मैं कल प्रिंट भी लगा दूंगा उधर, ऑफिस टाइमिंग 11 to 4। तो वो अगर नहीं सर सुनिए, अगर किसी को फीस भी भरना होगा ना कैश, तो आप बोल सकते हैं, वो नीचे कलेक्ट कर लेगा। हाँ हाँ हाँ, अब रखो ना सर। यस 11 to 4 ऑफिस खुला है, आप कभी भी आओगे तो वो मिलेगा। अब मैंने उसको बोला है कि आप इधर से एडमिशन होगा, और मैंने बोला कि मैं ब्रीफ भी कर दूंगा उसको जाके। हाँ ठीक है सर, ठीक है। हाँ चलेगा कोई बात नहीं। हाँ ठीक है ठीक। हाँ हाँ हाँ, अच्छा ठीक है सर, ठीक। हाँ हाँ Yes, yes. No problem. Yes, sir. Thank. Yes, sir. Thank you. Hello. Yeah, really sorry. Yeah, wait, one. See, again, you're
Sorry,
there.
you could attend that phone call but clear my lecture.
You are there.
Yeah.
Are you there?
Yes, sir.
Just listen again. Again,
Sir.
see again. Again, I'm repeating. There are three types of liquid. One is which will completely wet the wall of container. Other which is partially wetting the wall of container. Second which does not wet the wall of container. Now we have to explain why the surface of liquid which completely wets the wall of container is horizontal and which is partially wetting is concave, not wetting is convex. So I said for that I have to remember two things. One is adhesive force, other is cohesive force. Adhesive force means force of attraction between water molecule and this glass container ka molecule. Cohesive force is between water molecule. So I started like this. Consider liquids such as water which completely wets the wall of container. In case of this liquid, adhesive force is equal to cohesive force. So resultant lies at bisector. Bisector मतलब इसके ऊपर. Yeah, the resultant. So property of liquid is it will always try to adjust its surface in such a way that it is perpendicular to the resultant. So in case of this liquid, adhesive force is equal to cohesive force and resultant R lies on the wall of container. Thus, for equilibrium, surface becomes horizontal. एकदम self explanatory है. Diagram देख के I'm just telling surface becomes horizontal. Just complete two more lines, then second case we are. Very simple chapter, it is diagrammatic based. Written everything now?
Yes, sir.
Next line, right? Consider liquid which partially wets the wall of container such as kerosene. In this case of liquid, adhesive force is adhesive force in bracket F suffix A is greater than cohesive force FC as shown. Hence, resultant, I'm explaining diagram. Hence, resultant R lies outside the liquid. For equilibrium, the surface at the edges creeps upwards, hence becomes concave as shown. Just write this much, then I'm showing in the diagram how it is becoming concave.
Done.
Everybody has written full statement?
Yes, sir.
So can I clear?
Yes, sir.
Yes, sir.
Diagram showing why that surface creeps upward so that it behaves like concave. So FA is greater than FC. I'm completing this parallelogram. So resultant will make smaller angle, so it will come outside. This is resultant. Now, if you imagine tangent here, 1 minute. Huh? If I just imagine tangent here, so this tangent drawn to that surface, which is creeping at the edges, should become perpendicular to this because now it is not vertical. So for equilibrium, the surface creeps upward so that when I draw tangent, it is perpendicular to the resultant. So this is our case 2. When surface is not wetting completely, adhesive force is more than cohesive force, result comes outside. Therefore, the surface at the edges, they creep upward, and this, if you draw tangent, it will be perpendicular to the result. Draw diagram, second one. Yes. Is this diagram completed? First one, second one?
Yes.
See, case 3, consider liquid which does not wets the wall of container. Does not wets the wall of container. So inward force is larger. Now resultant is, see here. Is it inside or outside or on the surface? It is clear cut inside the liquid. That means in the container inside. So now that surface at the edges creeps downward, so that when you draw tangent, it will be perpendicular to the resultant. Follow third diagram also. Hello?
Yes, sir.
See, this is cohesive force. This is smaller adhesive force. Resultant will come inside. Then surface will creep downward, so that tangent becomes perpendicular. That is what I have drawn. So draw the write this heading. Consider liquid which wets does not wets the wall of container. Draw the diagram. Then I'm explaining.
Okay, sir.
Yeah. Yes, completed a diagram.
Yes.
Right. Huh? In this case of liquid, the cohesive force Fc is greater than adhesive force. Hence, resultant lies inside the liquid. For equilibrium, the liquid at the edges, creeps downwards. Hence, surface becomes convex. If completed, please tell, because new things we have to do.
Done, sir.
Next heading, right? Define angle of contact. Define angle of contact. Define angle of contact. So just now we saw there are three types of liquid: completely wetting, partially wetting, not wetting. Depending upon that, we have three type of surface: horizontal, concave, convex. So this actually moves exactly vertical along the sides of container. So we feel that it is perfectly horizontal. This creeps upward, this creeps downward. As I said, here if I draw tangent, here if I draw tangent, here also we can draw tangent to the surface which will fall on the wall of container at this point of contact. This angle is called angle of contact. This angle is called angle of contact. Now how do you define? Angle between tangent drawn at point of contact. Angle between tangent drawn at point of contact and wall of container measured within the liquid. Within the liquid means if this is surface, this is tangent, this is container, don't measure this way. You have to measure inside, within the liquid. This is the container, this is surface, this is tangent. We have to go towards the container, but within the liquid. This is called angle of contact. Again, I am repeating. Angle between tangent drawn at point of contact and wall of container measured within the liquid is called as angle of contact. It is acute for liquid which partially wets the wall of container and obtuse for which does not wets the wall of container, and 0 for liquid which completely wets the wall of container. Followed? Angle of contact. Wordings followed now? It is
Yes.
angle. Okay, right here. Angle between tangent drawn at point of contact. Angle between tangent drawn at point of contact and wall of container measured within the liquid is called as angle of contact. Next line right now. It lies between 0 and 180. It lies between 0 and 180. Next line. it is 0 for liquid. It is 0 for liquid which completely wets the wall of container, and acute for liquid which partially wets the wall of container, and obtuse for liquid which does not wets the wall of container.
Yes, sir.
Derive expression for excess pressure inside liquid drop, or obtain Laplace formula for liquid drop. Obtain Laplace formula for liquid drop. So if this is liquid drop, it will be acted upon by atmospheric pressure from outside. Suppose we write this as P external. Excess pressure means there is extra pressure inside. So always there is flow from inside to outside, means high to low. So suppose this slightly expands. This is very small change. Slightly we are telling. Expands. It can expand only when internal pressure is more. So if this radius is R and this expansion is dr, we want to find what is that extra pressure in terms of this R. Just draw the diagram. This is entire liquid drop. Yes, I'm clearing the diagram and everything and explaining theory aspect of this. Shall I rub it?
Yes.
Yes, sir.
एकदम सिंपल है, थोड़ा ध्यान से देखो बस कोई. Let pi comma pe be internal and external pressure. External is actually atmospheric, नाम खाली PE दिया है. Let PE be internal and external pressure on liquid drop of radius small r. Therefore, its initial surface area A1 equals to 4 pi r square. Let the drop expands by small distance dr. Therefore, its final surface area comma A2 will be 4 pi r plus dr the whole square. That is equals to 4 pi r square plus 2r dr plus dr square. Since dr is very small, dr square can be neglected. dr square मतलब पूरे का square है. It is not, t is small, r square. So this is one single term. So it is not like d separate and r square separate. Therefore, dr square can be neglected. Okay, just copy it in this. Is till this completed till this? Just can you wait for a moment? See further. Just wait, so that I can conclude.
Yes,
So,
sir.
yeah, just wait. Just therefore, change in energy, comma du is T into dA. So we get du equals to T into 8 pi r dr. Let this be equation 1. Now complete till this. 4 more lines are there.
Done.
Now change in energy is actually work done, which we got here T into 8 pi r dr. Everybody has done? Can I clear it off?
Yes, sir.
What is pressure defined as? Force upon area?
Uh,
So force will be pressure into area. So at this point, force is acting on this, which is pressure difference. And against that, because either say pressure, either say pressure. So net pressure acting is internal minus external, because internal is greater. And that force is making it to expand a bit by very small distance dx, dr. And work done, we know it is force into displacement. And work done against the force is also called energy. So keeping this concept in mind, let us see further. Force acting on drop, comma F equals to excess pressure into area at that instant. So excess pressure is P internal minus external, and area at that instant is 4 pi r squared. Therefore, work done during expansion by very small distance dr, comma dw is F into dr. So dw is P internal minus P external into 4 pi r square dr equation 2. Copy this also. From 1 and 2, dw equals to d. from 1 and 2, T1, W is TU, therefore this statement. Here I am cancelling from both sides. Pi I can cancel. 1 R I can cancel. 4 2s are 8. Therefore P internal minus P external is 2T upon R.
Done, sir.
This is formula for excess pressure inside the drop. This is formula for excess pressure inside the drop. This is formula for excess pressure inside the drop. For liquid, if it is not drop but bubble, so just remember we have to multiply with 4. So it is 4T by R for bubble. That's all for today.
Done, sir.
Yeah, that's all for today.
Okay.
Just revise and keep. Chapter is a bit lengthy. So we'll be able to complete by next week with numerics.